This video is going to be about adding and subtracting vectors and multiplying by a scalar. And so let's say that you have a vector u, and in component form the horizontal component would be u sub 1 and then u sub 2, and then let's say we have vector v, and it would be equivalent to v sub 1 and v sub 2. And when you're working with these vectors, you can do a lot of things. You can add them, you can subtract them, you can multiply them by a number, and it's pretty straightforward the way that you do it. Let's just say for a fact, and this is just algebraically, if you were asked to work with these things algebraically. I'll talk about graphically in a second, but let's just say u equals 3, 5. Let's say v equals -1, -3. So if you have these vectors and somebody says, hey, let's do 2u, let's double u. So for question number 1, let's double u. Well, it's pretty straightforward. When you multiply a vector by a number, or a scalar as it's called, all you do is distribute. So 3, 5 like that, and you're just going to take 2 and multiply by both 3 and 5. It's going to get you 6 and 10. The neat thing about that is what it does is it's not just doubling, right? It's not just doubling the numbers inside, but what it's really doing is it's doubling the magnitude. So if you were to think about it this way, the magnitude of u would be found by doing the square root of 3 squared plus 5 squared. And so the magnitude of u would equal, right, square root of 9 plus 25, which is 34. If you take 2u and you do the magnitude, so this is 2u right here, this guy. If we do the magnitude of this guy, it's going to be the square root of 6 squared plus, right, 10 squared. And so now we have the square root of 36 plus 100, 136. And it's not too crazy, but if you think about it, you would have a 4 in here. So 4 times, and that would be 34. And if you take a look at that, right, the square root of 4 is 2. And then what you would be left with is 34 underneath. So take a look, the magnitude of 2u is 2 times the square root of 34, so it's literally double the amount. And so when you're multiplying by a scalar, it's not just multiplying the vectors on the inside or the components by 2 or 3 or 4. It's actually doubling or tripling the magnitude, which is really interesting, or the length of the vector, if that's how you were taught the magnitude. Also, algebraically becomes pretty straightforward if you have to do lots of things with these. So if you had to do like 3u minus 4v, it's basically an algebra problem. You just take 3 and you multiply by u, so 3 comma 5, and then minus 4, and then -1, -3. And you just distribute doing good math. So you would have 9 and 15. And you can just distribute the 4 and keep it subtraction, or you can distribute a -4 and call it addition. So I usually like to distribute a -4 to both those, so that would make it 4 and 12. And so therefore we'd be adding those two vectors now, right? So plus a negative kind of that way. And so then you'd have 13 and 27. And that would be your new vector that you would get, okay? So that's how you combine and do vector operations with vectors algebraically. You can also do this graphically, and the way that you do it graphically is pretty neat. What you do is you create a parallelogram. And so let's go back to u and v. So u was u sub 1 and u sub 2, and v was v sub 1 and v sub 2. So let's just say you had a graph. with u, and so I'll make u be orange. How about that? So here's u. Now let's do a vector v in yellow, and let's just do it this way. So that's vector v. If you're going to find the sum of those two vectors, all you have to do is create a parallelogram. So at the end of vector v, I'm going to put an identical vector u. It's my best to make it identical. And then at the end of vector u, I'm going to put an identical vector v to the best of my ability. And it should create a parallelogram since the vectors opposite one another are identical. And the answer is going to be the diagonal from the origin to where the two arrows meet. So that resultant vector is your answer. And you can do that with any two vectors. One thing that could get interesting is, as we talked about before, if you make another graph, and let's say that we want to find the sum of 2u plus v, and let's say that this is u right here, and let's say that v is this guy right here. That's v. Okay? And so if you have to do 2u plus v, then remember, what does 2 do to this vector u? Well, it's going to double its length. So now you're actually going to have two of them. And that's what I'm going to put at the end of v, is double the length. And then at the end of 2u, excuse me, I'm going to put the vector v. And my answer is going to be the resultant vector that goes from the origin to right where the two arrows meet up. And this is my answer. So, right, the answer here would be 2u plus v. It's that green diagonal vector. And that's how you add them graphically. So whatever the combination of things are, that's how you would create the parallelogram. The one thing I will say, just so that before we leave here and wrap this video up, the one thing I will say is if you have to do subtraction, you should know that the vector reflects over the origin. So let's just say that you have u here, that's u, and let's say that we have v down here, this is v. So if you have to do, say, u minus v, this would be the same as u plus negative v. So normally in the coordinate plane, when you have a negative in front of a variable, you usually think, okay, I should reflect that over the x-axis. But you have to remember a vector has both horizontal and vertical components, so it's actually going to reflect over the origin. So this would be negative v. If I could draw this in, draw it well, it's going to reflect right over the origin, and that would be negative v. So if you want to do u plus negative v, you're going to create your parallelogram with negative v and u, right? So there's my parallelogram forming. And then once again, from the origin to the diagonal, that's going to be our vector. And do your best to use a straight edge. My app doesn't really allow for me to do that, but you should use a straight edge and try to keep everything really neat so that it looks like a parallelogram and you can get the best result. Alright, thanks for joining. Have a great day.